Hi everyone. Great to be here. First time for me here, but I already feel at home because it's about engineering. And although I'm in a bit of business development and marketing today, I used to study as an engineer, so that's one thing. But then I also noticed at the wall of 100 things that changed the world in terms of engineering, there's also a TomTom device in that wall. So it was like coming home. The connected car, will that be our next smart thermostat? So I'd like to talk about what we do with connected car data, what we're going to do with connected cars, and how we also use the partnerships with OEMs with that, as well as the outlets of importers and dealers and leasing companies and rental companies. But to start with is first to take the comparison with the thermostat. So who has still an old thermostat like these at home? There's only a few. Okay, so you're really digital marketeers. Because this is where you use the user interaction to just control the temperature, clear. Then came this guy, which was self-learning. So it would still need the control, but it would learn from the data as an input. And that's also where we started to learn about smarter routing, because first we gave routing from A to B, but we started to collect data, more data, connected car data, to do it better, to become a taxi driver, to become a London, so everyone could become a London taxi driver. And of course, that starts with a map. We are also a mapping company after we bought Teleatlas a couple of years ago. And the map making is a very complex process. So first we had to do that with paper maps. We had to go to public authorities to collect all that data. Then, of course, also through engineering, there were satellite images and we could turn those images into maps. So that already saves us a lot of time, but we still had to go down to the earth to see where the traffic signs were and what the street names were. But then one of our founders came to the idea that if we would include, if we would ask our users of our navigation devices to share their data with us, you could say connected car data. Back then it wasn't connected yet because you first had to update your navigation device and then we would ask you if we could also get the collected data from your device. Nowadays, of course, these devices are connected and we also get it from different sources. But that allows us to also create this map. And this is not the map of Europe, but this is just a couple of months of data from our database that we plot on a black background. So we have anonymous GPS measurements from our community, our own community, but also from other cars coming in. For example, the OEMs where we supply the traffic information. And on a hourly basis, we get in 1 billion measurements to our databases in Amsterdam from all over the world. So from the US, from London, from Portugal, from you name it, everywhere where we have devices driving around. And that's great stuff because that allows us to get a better insight of what is happening on a certain street. So we now know where the streets are because of the satellite imagery, but we can also now say on all these different road segments what speeds are at that moment in time. So what you see here are graphs, and in the graphs you see the speed and you see the hour of day. So you see from midnight to midnight, the colors are representing the different days of the week. So for this little road segment, we then know where maximum speed probably during the night is 80 kilometers an hour. You see the morning rush hour appear. Then of course speeds go up again, and then you see the evening rush hour, which typically is a bit longer. But you also see, of course, that on Sunday and Saturday there's less traffic jams of congestion. So you see, people. This is probably a Dutch road because you see the purple line where people are leaving home on Friday early. That never happens in other countries. So suddenly we can use that information in smarter routing because then you become a London cab driver because you have that local knowledge. But we wanted to take it a step further with the connected car data because you never know what's going to happen. You never know when someone is going to crash into someone else in a tunnel or having an accident or trucks falling over and pigs running around on the highway. So we also wanted to cover this problem. So that's where we started collecting a lot of data, not only from the cars itself, but also from other sources. So we are collecting the data from the in-dash GPS devices, our own personal navigation devices, fleets, so trucks driving around with telematics, giving us data, or service engineers, or Uber taxis, maybe apps on GPS devices. So we happen to have a couple of partnerships with fruit companies in the world, which are delivering us data, but also local data from governments, so local roadside equipment, so inductive loops or traffic cams for journalistic data. And with that, we process data from over 500 million devices on a daily basis in a couple of milliseconds, so faster than the 100 milliseconds for real-time billing. That is then distributed to that whole community of our customers. They can be our own customers. They can also be the in-dash navigation devices in the in-dash. We do that we calculate that for 100 million kilometers on a daily basis. So that's and just to give you an idea, in the Netherlands, the whole road network would be 120,000 kilometers. So that's really a huge amount of roads where we calculate that data for. That's what we can do with anonymized GPS data for traffic information, but it's of course also cool if we could do something for the future car. That's where we go to high definition mapping and autonomous driving. Because that database that we have right now is consisting of 19,000 billion measurements. That's really a lot. So if we would start collecting that data today, with the amount of data flowing in today, it will take us 5 years to fill up that database. But the cool thing is that now that we have it, we could also use it for other purposes. And we would have never thought about using it in that way 10 years ago. And one thing, for example, is that if this is a snapshot of a map in our database, you see the roads and you see some rivers. If we then do a layover of the GPS data, we suddenly see people driving through the water and through the fields. Probably either it's a 4x4 with some very tight ceiling, or it is just a civil servant who forgot to send us the memo that they build a new road. So this is a good indication for us to start collecting some more information. And we need to know, of course, what exactly is going on there, because now we know there's probably a road, and we see that's probably in one or two directions. We know probably what the speed is, but we still need to have the details. And that's what we do with our mobile mapping vans. Probably you would call this car with the cameras and sensors a street view car from Google, right? Well, that's wrong. That's not the original name, because you see this. We started off with this. So the right name is a mobile mapping van. A mobile mapping van even before you had Google Maps, because Google Maps started with using our maps, the TomTom maps, before they built their own maps. So next time you see this, you don't talk about a street view car, you talk about a TomTom mobile mapping van. We would put a student in there with his girlfriend or boyfriend, and they could drive around, and in the meantime we also collected some data. Right now, of course, it's a bit different. So this is more like the fleet that we have today. The equipment on top is more expensive than the car itself, maybe twice as expensive as the car. Big computers, so no room anymore for the boyfriend or the girlfriend in the car. And the cool thing about collecting that data for the map making, for normal navigation, is that we also have the 360 camera on top of the vehicle, or a LiDAR. So a laser, a combination of a laser and a radar. And that's scanning the whole surrounding. We do that for the map making and the 3D models of the map. But we can also use it for high definition mapping for future cars. So in this little movie, what you see on the left-hand side for the viewers and the right-hand side. So the left-hand side is what we would see as a driver. So that's the camera view. But the LiDAR is seeing this. So he sees a 3D image of the surrounding area. And we're collecting that data as a reference for the self-driving car. Because the trouble with a self-driving car is they need to know exactly where they are on a lane. So not just on a road. First of all, they need to know the lanes. And secondly, they need to know centimeter accuracy where they are. But we need to give them a reference because the GPS signal coming from space is not accurate enough. So we use the expensive sensors on top of our vehicles to model the world, but the problem is that's too much data. So if we would have to put all that data into a map and then put it in every car, we would have to also give them something in the back, like really a lorry, to also have a little mini data center to get this 3D data with them. So what we did is, and that's what you see in the movie, we turned that 3D image into a 2D image. And we use the colors to represent the 3D image. So we make it much smaller, and it only takes a couple of kilobytes per kilometer, and then it fits into a car. And that's being used right now, for example, by Volvo in their Drive Me program, the HD mapping as well as the road DNA, to see how that interacts with the self-driving cars. And then Will already talked about connected vehicles. We've been connecting vehicles for more than 16, 15 years, but that was in traditional fleet management. So we were putting in devices, aftermarket devices. Once we acquired a company called the Data Factory, a German company, which made these boxes, and we would put it into lorries and light commercial vehicles. And they would use it for tracking and tracing, so really a dot on the map. That we added the functionality by combining it with the screen, so you could also talk to the driver, you could send him an order, so where does he need to go to, you could see where he is in the flow. We also added devices so we could read out driving behavior. And that made people like this guy happy. You see him smiling, he's the fleet manager and operations manager of Xerox. And he was saving fuel, and he was saving on insurance and travel time and maintenance. But moreover, the business case for him was that he would be more productive, because his engineers, instead of doing 4 work orders a day, they could do 5 work orders a day. That was the real saving for this guy. So not necessarily saving on the fleet, but more on the productivity. And like I said, this is really where the engineers, where you want to see where they are on the map. So see the dot on the map and have a map-centric view of the world, and then doing it. So that they could do that in our online user interfaces, or they could integrate that with their planning tools. That was on the back office side, and we still do that, of course, but also on the driver side. So we had the user interface, so the driver terminals, and on the driver terminals, we could get rid of this guy. So this is the trainer. He would do the driver training, learning them to be more fuel efficient. But they would do that maybe once a year, and then throughout of the year, of course, after a couple of weeks, the driver would forget all about his tips, and he would just go back to his old behavior and then spending too much fuel, etc. Whereas if we would give him the feedback from the telematics device directly to the screen, we could give him advice on when to let go of the right foot, when he's nearing an intersection, because we now know, because of all the connected car data, where things are slowing down, where there's a roundabout, where there's an off-ramp, so where he can let go of the pedal for a more fuel-efficient way. But we can also see if he's taking the roundabout on 16 wheels or on 8 wheels, and then give him a warning. And he doesn't have to get that warning after 1 month from the fleet manager. No, he knows already immediately that he did a bit too much of the harsh steering. Now that technology, which is in our database, we're using for connected cars. And going back to connected cars, so more for consumers, the non-operational or financial fleet management. So we're making, you could say, we're making this standalone thermostat that is self-learning into something which is connected, where you can see things remotely and you can also operate things remotely. That is what we also see that the automotive industry, of course, is doing. PSA is equipping most of their vehicles, but I don't have to tell the PSA guys that most of their vehicles already with a line-fitted box to bring that connectivity. And if we talk about connected cars, I want to make the distinction between the infotainment bit, where my colleagues from TomTom Automotive are delivering services. I'm not talking about the Wi-Fi bit, the entertainment bit. I'm talking about getting the data from the car about the status of the vehicle, driving behavior, mileage, these kind of things, the telematics data. And BMW recently announced that they will open up the connected drive data for third parties. So BMW car data, which is allowing the user to have control of the data, because the GDPR, I'm not sure if you heard about that, probably you do as digital marketeers, is coming in effect May next year, and that says that anyone with data which is on the web needs to have that overview of where the data is going, who sees that and also can anticipate on that data. Now, if this is happening, is that then also the end of TomTom Telematics? Because you could say, well, we're equipping aftermarket vehicles with that technology. No, it's more an opportunity for us. We used to be in fleet management, and we see indeed the trend of OEMs equipping their cars with connectivity, but it's always for their own brand. It's mostly for the new cars, and also some, right today still for the more expensive vehicles. So there's a gap in the middle where we have car importers, so what we call the connected car service providers, or the car service providers, the importers, the dealer groups, the car leasing companies, but also the rental companies that build their service around the car aftermarket, which are operating a fleet which is mixed. So they are either selling from one brand multiple types, so also the lower cost brands, or the leasing companies which are operating maybe 150 types of brands and types of vehicles. So they want to have that overview of the data and offer the same service to their customer. And if you then talk about those additional services, the drivers, the thing that we did for PON, the Volkswagen importer in the Netherlands, we created the app for them. So the aftermarket, they're installing to all the connected cars our box, and we created an app in which they could have all kinds of services. So find my car, do the business and private mileage for those countries where that's for the electric vehicles, the battery health check, or also for the normal vehicles, if the doors are locked or unlocked, explanation of if a dash light comes on, what that means. But also integrating recovery services. So making sure that if someone breaks down, that behind the button of the recovery service is the local dealer group. So you make sure you get the car to that dealer instead of maybe a non-authorized dealer. Movement alerts, maintenance alerts, so they can see when they need to have that maintenance, and then of course schedule that appointment. So again, a drive or lead gen for the after sales guys in either the importers or the dealer groups. Driving behavior and odometer. And the driving behavior and the odometer, of course, is something where we can work on for predictive maintenance for the future. So depending on the driving style, when do you get in this vehicle? Now, that's cool. So that's the connected thermostat, you could say, the connected car for the driver. You can see what the status is. And that's already giving then also information to the mobility manager. So that could be if it's a private user, it can be the dealer, or that can be the importer that sees that data in overviews, in dashboards, or that can be if it's a leasing company, that can be the mobility manager at the company themselves. So the guy that's responsible for managing the fleet, having an overview of a non-map-centric overview. He doesn't have to know where you are at a certain time, at a certain moment in time, but you want to know what the status is of the car. You can see details of driving behavior. But of course, you can also see, and now it becomes a bit more interesting for you guys, what kind of driver someone is. So is this gentleman the typical sales guy who does a lot of mileage, 40K or more a year, and he needs a Golf, petrol or diesel? Or is he only doing this inner city trips, and can you offer him better a BMW i3, because he is really the perfect candidate for an electric vehicle, maybe even a full electric vehicle? Or is he more the family guy who does a lot of the trips during the weekend with probably his kids and going to southern France to his little outhouse? So he needs the more bigger car with indeed the diesel because the larger range. Or is he does he only drive locally to the hockey or the rugby fields, and can he also does everything with the Tesla X? That's also the car data, of course, that we're getting. So we get the short trips, the long trips, the driving behavior, when he's driving. And you don't necessarily have to know where he's driving. So you could do bespoke car advice, or add that to the algorithms that are already, for example, being used by IgnitionOne to even get a better target on the driver. And next, to add a bit more value, things become interesting because everything becomes connected. So we're talking about connecting the car itself to the driver, but of course the car is also becoming connected to its surrounding. The thermostat is becoming connected to everything. I'm not sure, does anyone know the platform If This Then That? Yeah? Imagine that the car would become If This Then That compatible. BMW already did it with its BMW Labs. So if you drive home, your thermostat already knows when you're coming home, or for Spain, your air conditioning knows when you're coming home, so it can turn it on before you're home, so it's cool. And that's also what we want to do. So we have a platform approach where we combine all the connected car data, either from the larger fleets in the platform, and you can see that in the map-centric view, but we can also see that same information in the apps or in the other user interface. But we can also connect to the outside world, because we made it an open platform. So with APIs, we are able to connect to the rest of the world. And that's also what we did for Volkswagen in the Netherlands. With the app that was there, we connected that app to, and this car is now driving into a parking zone, an on-street payment parking application, so a third-party app. And by making that connection, it becomes possible when you enter a zone where you need to pay for on-street parking, you get a pop-up, so you never forget to pay, so you never get that fine anymore. But more importantly, that after you're done parking and you drive away again, the car itself, of course, knows that you're driving away, you're driving out of that zone, you're starting your engine, and he will stop the payment, so you never pay too much anymore, because I tend to forget, of course. And the other thing is that we included also the things for permits. And that is, of course, when it becomes even more interesting for the driver, because that's where the added value becomes more than only the way of transportation. It really brings that convenience to the driver. And when we can also then interact with the world around us with the connected cars and include that data into, for example, tools like IgnitionOne, and bring better services, not only for when the driver owns the car in terms of recovery, but also helping him with selecting a new vehicle, then of course it becomes really interesting. So that's it for me of what we do with connected car data and what we're going to do with connected car data. Thank you very much.